Hey everybody, today we're going to be talking about slope. So we're kind of moving into slope and linear equations here. So our goal for today is we want to be able to recognize the different types of slope there are, as well as find the slope if we're given a graph. So nothing too difficult here. So let me show you through it and you guys will be good to go for some practice with this. So what we call the one second here. What we call the slope represents the rate of change of a linear function, or what we generally refer to as the steepness of a line. So generally, the bigger the number we're dealing with, the steeper it's going to be, whether that's negative or positive. And if we have a really small positive or negative number, that slope is going to be pretty shallow. And we'll kind of see what that looks like and what that means later on. So today and all the time, we're always going to be dealing with four kinds of slope. There's four kinds of slope we can deal with. So if our line is growing upwards as we move from left to right, then we're kind of can think of that as like adding on to grow upwards as we move. So because we're adding on, we're going to call this a positive slope. And then thinking in the other direction, since we're going downwards as we go left to right, our line is going down, we can think of going down as being reduced or subtracted. So this is what we're going to call a negative slope. And then we have a line that does not grow at all as it moves from left to right. It's staying completely horizontal. So we call that a zero slope, or we can use the number 0 to represent that slope. And then we've got a straight up vertical line here, and we'll talk about why it's called what it is here pretty soon, but this is called an undefined slope. All right, so we're going to take a little time just to get to know each one individually a little bit better here. So we're going to kind of draw what we see happening. So a line that slants up to the right, up and to the right is our slant. This was the positive slope. And then a line that slants down as we go to the right, that was our negative slope. And then we had the horizontal, completely flat line. It's not growing or decreasing. So in the middle of positive and negative is 0, or like we said, we can write the number. And then a vertical line straight up and down is what we call undefined. And like I said, once we get past a little bit on the next page, I will kind of revisit this and show us why we call that undefined and what it means. So go ahead and flip your paper over, and we also want to today be able to find the slope of a line from a graph. So to determine the slope of a line given a graph, we will need to locate 2 points on that line. So we're going to start with the point that is furthest to the left. We always want to start with that left point because that's going to help us determine whether our slope will be positive and negative from the move we make from there. So we're going to call this point A. Then determine how far up and down and to the right we must go to get to our second point. And we're going to call this second point point B. So how do we write slope? I talked about this quite a bit last year if you had me. Most of you did. So slope is always going to be, well, we're going up and down first. So that's what we're going to call our rise. So up and down. And then we have our run, which goes on the bottom of our fraction. So that's going to be our left to right movement here. Left and right movement, horizontal. So we've got vertical movement divided by the horizontal movement. So let's see what that means in action here on our graph. So we are starting with our furthest left point that it gives us right there. And we're trying to move to this second point. So we want to do our rise first. So our rise, when we notice that our line is going down when we go left to right, so this is going to be a negative slope, and let's see that happen. So we're going to drop 1, 2, 3, 4. And because we're dropping, we're going from a positive value to a negative value there. So that drop will mean that is a negative 4 here. And then divided by our run is going to go on the bottom number, our denominator. So we've got 1, 2, 3. So our slope here is negative 4/3. We always want to reduce our fractions if we can, but this guy is non-reducible. So we're going to move on to the next one. So we're starting with our furthest left point here, and we're counting our rise and then dividing it by our run. So our rise for this point to get to this one is going to be a rise of 1, 2, and our run is going to also be 1, 2. So we're going to have a rise of 2 divided by a run of 2. Always reduce your fractions, so 2 divided by 2 is going to give us a slope of 1 there. All right, so now that we're kind of counting slopes and figuring this out, seeing that slope is rise over run, let's go revisit these horizontals and undefines. So zeros and undefines. So let's say I pick 2 points on this horizontal line, right there and right there. Just for argument's sake, let's say that their distance between them is 2. So if we count slope as rise over run, well, what is our rise between these 2 points? Well, it's perfectly level. We didn't go up and we didn't go down. So our rise is actually 0. And then I picked those 2 points and gave a distance of 2 to help us out here. So our run for this guy is 2 specifically. But 0 divided by any number there would give us a slope of 0. So that's why horizontals are 0. Same thing with our undefined. If I pick 2 points, let's say that guy, and once again, just for argument's sake, let's say that the distance between them is 2. Well, our rise between these 2 points is 2, and our run is 0. And if you try to type anything divided by 0 into a calculator, it's going to give you undefined. We cannot divide by 0, therefore we cannot assign it a number. It's undefined. And if our rise was 7, but it's a vertical line, we still can't divide by 0. So that's why any vertical line is always undefined. All right, circling back to finding some slopes here. Just wanted to revisit that and show why zeros and undefines are what they are. So, just like before, start with your furthest left point here. Our rise will be a negative 1. And our run will be a 1, 2, 3 for this guy. So our slope is negative 1/3. And then we have so the next example, number 2 here, starting with our furthest left point, going to our next point that it gives, we have a drop of 1, 2, 3. So that's a rise of negative 3 and a run of 1. So as I mentioned earlier, we said whether it's positive or negative, the smaller the number is, or the closer it is to 0, the kind of more shallow this line is going to end up. So that was a slope of 1/3. When we change it to a slope of negative 3, we see that our line gets much, much steeper as it goes. And the same thing will happen for positive numbers. The bigger it gets, the steeper our slope will get. And then the smaller the number, the shallower our slope. All right, number 3, we're starting from left, moving right. So we've got a rise of 1, 2, 3. Rise of 3, run of 1, 2. So that is a slope of 3/2. Now I'm going to show you something a little bit interesting here as well. So number 4, if you have more than 2 points on a line, which ones do I pick to find the slope? Well, let me show you something interesting here. So if we pick, let's say, these 2 starting points, we've got a rise of 1 and a run of 1, 2, 3. So this slope will be 1/3. Now, let's say that I pick, I don't know, maybe this point and this point to do the slope instead. Got a rise of 1 and a run of 1, 2, 3. Slope of 1/3. Okay, but what if I picked the furthest 2 points? It's got to be that that number is going to be different, right? Well, let's see what happens. We've got a rise of 1, 2, rise of 2, okay. Looking like my hypothesis for a second was correct there. But we've got a run of 1, 2, 3, 4, 5, and 6. Run of 6. And we always reduce our fractions here, so this is going to give a slope of also 1/3. So all of these being equal to each other, that's telling us that the slope of a straight line is always the same no matter what 2 points you pick. So you will always get the same slope there on a line. Cool. So we discussed the 4 different kinds of slope. We've got positive, negative, 0, and undefined. We went over rise over run to find slope from a graph, which then led us to kind of the explanation for zeros and undefines here. And then we did some practice finding our slope on a graph and realized that as long as you have any 2 points, it doesn't matter which 2 you use to find your slope, it's always going to be the same. All right, so you're going to have a little bit of practice here, kind of identifying your slopes based on a graph or a verbal situation. You'll have to draw a couple as well. And then we'll have to find some slopes of all these lines here. All right, so we've got all the information we need to know from our notes here. You'll get your assignment and do your best on that. Thank you, and I'm sure I'll be talking to you guys very soon.